Okay, hello everybody. This is my video presentation of the Sandy project. Okay, let's get going. Okay, so Sandy is a B2B platform that allows businesses of all sizes to send packages throughout East Africa. What they were looking for is a solution that's going to help them estimate the estimated time of arrival of their packages. This is the time from pickup to time from delivery drop-off. How this will help them is it'll help them communicate better with their customers with regards to when they can expect their packages to be received. And also it'll help them manage their resources better cost-wise, so that they know where to allocate what money. Okay, so what we received here is about 20,000 records on our training data set. About 7,000 were split into the data set, into the test data set. We also have a riders data set here that gives us information about the riders themselves. So we have information about the orders themselves, order number, user ID, etc., etc. The time it was placed, the confirmation what time the confirmation was sent through to the client. We have the we have the arrival pickup times, we have the pickup times themselves, we have arrival at the destination times, which is not in our test data set. And then we have rider metrics that gives us information about the rider ID, number of orders that they've delivered, the age since that the rider has delivered their first order, average rating, as well as the number of ratings that the rider has received. So we would start off essentially here by importing our Python packages, everything from NumPy to pandas, our visualization stuff, time manipulation, maths, scikit-learn, different packages for linear regression, retrogression, train test split, as well as the standard scalar. We go through, and then we import our training and test data sets. We have a look at the overview. On our training data set, first thing we would do is to go and identify our target variable, which is on our top left hand, so our far right hand side here. Everything else is our predictor variables. Next, this here is our test data set. What we were expecting from our test data set is we don't have our target variable here. It wasn't provided, and this is what we need to work out. What we notice is that we do have categorical, numerical, and time variables here. Those are the data types that we've got there. Here we're just finding out that we're just confirming that we don't have the same data, the same columns here, and identifying which ones those are. Our workflow is then we merge our data sets, both our training and test data set, with our rider data set. And from there we move on quickly to our training tests, to our EDA, so that we identify, for example, here we're identifying our data types per column. Here we'll be identifying our missing data. What you see is that our temperature and precipitation in millimeters does have certain null values. These are the percentages that you'll see here. Here we're converting our time variable into a more usable format in hours, minutes, and seconds here. This is where we're going through some of our visualizations, identifying the different temperatures throughout the day, the variability. Here we're looking at the variability and the distribution of our time from pickup to arrival. We're noticing here that we do have some outliers here that we'll have to deal with, so that they don't affect our model. This is where we do our descriptive statistics here. We're having a look at our mean and our standard deviation, for example, for our time from pickup to delivery, as well as the distances usually that they deliver from where they pick up. Same thing gets done for test data sets. Here we have a look. Here then we split our train data set and our test data set into the different kinds of variables, which is numerical variables, time variables, and objects, so that we can manipulate so that we can process them separately. Okay, here we move on and create our correlation matrix to see initially what we have before we do anything. Here we go about the process of encoding our time data. We go about creating trigonometric functions with our time data so that we can have time and date data, so that we can have the ability to look at the differences in time in terms of a circular reference. Here we go about encoding our categorical data, and then we put all of it together here into a master data set. So that we can then create a second correlation matrix after we've done our encoding. Okay, this is what you're looking at. Here. After doing some variable selection. Okay, so we're putting these together. After we're creating our base model here, what we're doing is we're separating our numerical columns from our categorical columns that have been encoded, so that we can individually scale them and then combine them once again before we do our train test split here. Then what I had a look at is I tried linear model, I tried a ridge regression model, and a decision tree model. What I found that those weren't performing as well, but the random forest model worked much better with some tweaking of the variables. What I think I could have done better with this is maybe use better methods to select my variables. That's what I think I can improve here. Thank you.